beautiful women produce more beautiful women. And this evolutionary action over a period of time creates an accelerating rate of pulchritude among the females, while the men continue to be selected for something else, and it isn't their good looks. So that's going to be the thing that we're going to pursue this morning, the decline of the male and the rise of the female. And so with that introduction, I'd like to ask our first speaker, Dr. Shanna Swan, to come up here on stage. There she is. Dr. Swan.
Good morning. I'd like to start by asking you to think about a very large experiment in which millions of animals are exposed to thousands of chemicals in their food and their air and their water. A dark scenario, sounds like sci-fi. But I'm here to tell you that we are participating without our permission in just such an experiment, and we have been for perhaps the past 50 years. So, is this a problem? Do these chemicals in our air, water, and food actually harm us? I think we have a serious problem, and Moses has started to allude to it. Over the same past 50 years, sperm counts have declined 50%, 1% per year in Western countries. Testosterone has been declining at the same rate. Testicular cancer rates have been rising. What do these conditions have in common? These are all conditions that could be resulting from problems in the developing male when he's in the fetus. So I want to talk to you about this problem today and tell you that I am extremely concerned. So I'm going to start by going back quite a long time and talking about a carcinogen which was sold as a pharmaceutical, and then talk about two specific environmental chemicals. In 1947, this drug, diethylstilbestrol, was marketed for use by pregnant women to prevent miscarriage. It had never been tested for safety. It was discovered because scientists were looking for an orally active estrogen to use as a pharmaceutical. They lucked out with this one. It was cheap, it was widely distributed, and it seemed safe. It seemed safe because the children that were born looked fine. But they were not fine. They were not fine. And it turned out that 20 years later, many of these girls that were born to mothers who were exposed developed rare and terrible cancers of their vagina and cervix. And there were many other adverse effects. This was an eye-opener for many scientists because we'd never heard of such a thing. A chemical that the mother took that could affect the fetus 20 years later. Chemicals that can interfere with our hormone systems are, we call, endocrine disruptors. They can affect estrogen, testosterone, thyroid, and so on and so on. I'm going to talk about, first, just briefly, one other chemical that affects estrogen, and then concentrate on those that affect the hormone that's most important for the male development, testosterone. So, just coincidentally, the person who discovered DES, Sir Charles Dodds, also discovered that a chemical that had been on a shelf for a long time, bisphenol A, or BPA, actually was estrogenic. It wasn't as effective as DES, and so it was DES that became the pharmaceutical, but BPA was put into our babies' bottles. And it's there today. It's a chemical, it's a plasticizer that makes plastic strong and hard. You might have seen it in Nalgene bottles. It lines our tin cans. And more evidence is suggesting that it's not good for the human body. But I'm even more concerned about another class of chemicals, because this class of chemicals has the ability to lower the testosterone in the fetus. And these are the phthalates. A terrible word, hard to say. There's a lot of them. I don't actually know how many. We're finding them all the time. It's a big class. They do different things. They have different properties. I'm going to concentrate on two of them today. Simple to say, DEHP and DBP. And so we can ask, well, is it plausible that the small amount that could come out of a baby bottle or a child's toy could actually harm us? That small an amount? People that make these things say, no, it's too low a dose. Let's look at low doses. To answer this question, we have to ask the rodent, because we can't experiment with these drugs, these chemicals, on humans. It wouldn't be ethical. But if we look inside this developing rodent, we see that each one of these little pups are surrounded by two neighbors, and the sex of the neighbor of this pup actually influences his development. What I want to tell you is that a male that's between two females has a little less testosterone than a male that's between two males. So he gets a little bit less testosterone. How much less? Less than 1 part per trillion. Tiny amount. 1 drop in an Olympic-sized swimming pool. And you know what? That affects his development. So yes, small doses matter a lot. This is a simplification of a complicated story, but the genital tract is undifferentiated originally. It will become female, the default, without the presence of testosterone. And this has to be present at the right time. So the time that the male needs to see that testosterone is a little teeny window. In rats, it's 2 days, and us, we're not sure exactly, but it's in the first trimester. So here's the story now. The rat, or we, need a small amount of testosterone, but enough at the right time to make the male completely masculine. So what happens if that doesn't occur? So let's ask, what makes a male and a female different? Okay, so there's some obvious ways. Obviously, testosterone is different. The size, the genitals are different. But there's one measure that I've been studying a lot that turns out to be really important, and that's called the anogenital distance. It's the distance from the anus to the genitals. And this has long been studied by toxicologists because it's really visible to the naked eye when a pup is born. The other things are harder to see, and moreover, it's twice as long in males as females. So you can just hold the pups up, look at this one, this one's big, this one's small, this is a male, this is a female. It's very simple. The problem is that this can be affected by the presence of testosterone, and if there's too little testosterone, that won't be completely masculine. So now I want to talk about some of the phthalates that can actually affect this. The two that I've told you I was going to talk about is DEHP and DBP. DEHP is the really, I think of it as the bad phthalate, the worst phthalate. It's the one that's controlled in drinking water. It's in our shower curtains. It's in our homes in many, many ways. It's a very, very common occurrence because it's in polyvinyl chloride, which is in so many products that we use. And it turns out it's also used in our hospitals. It makes the tubing soft and flexible, so that's good. And this is needed in the intensive care nursery. But as a result, this baby is getting a lot of DEHP. The other phthalate that I'm concerned about is DBP. And that's also a high-volume chemical. It's also in PVC, but it's also in our cosmetics. It's in lacquer, it's in nail polish, it's in hairspray, and both of these have the ability to lower fetal testosterone. Let's look at that in the mouse. So remember the testosterone peak that I showed you? Here's what happens when the mother is exposed to DHP. At the critical period, no peak. The testosterone has been reduced. So what happens? Well, Mickey is not going to be so different from Minnie anymore. At 0, there's no exposure. Male is twice as big as female. And then, if you give the mouse more and more DHP, that anogenital distance is getting more feminine. And notice that the females are not affected. What else can happen? Well, when the mother is given DHP, there turns out to be a whole cluster of things that happen. We call that the phthalate syndrome. Smaller penises, scary thought. Undescended testicles. This is in a newborn. Does this matter? Well, it does matter. It does matter because this mouse that's got a short anogenital distance when he's born will have a short one when he's an adult. And this whole cluster will affect his sperm count and his fertility. So lifelong consequences of phthalate syndrome at birth. Okay. What about us? Here is a human fetus, perhaps getting a small amount of DHP or DBP. We asked that question, and we conducted a study to find out. So what did we do? We imitated the rodent study by taking urine from our pregnant women. Now, we needed to do that because you can't ask somebody, how much phthalates are in your body? I can ask you if you smoke, I can't ask you this. I have to get a sample. And we'll do that by taking the urine from the woman and then looking at the body's breakdown products of the phthalates called metabolites in the urine. I'm going to concentrate on one metabolite today. Its name is MEHHP. It's a metabolite of DHP. It's enough to get my story across. And then we brought the children back and we examined them very carefully using an exam that tried to capture the features of the phthalate syndrome in our boys. We found a lot of phthalates in the women's urine. We categorized them into low levels, medium levels, and high levels, depending on if they were in the lowest 25%, the highest 25%. You get the picture. And then we related that to their children's anogenital distance and other outcomes. This is a distribution of the anogenital distance in our approximately 300 children. Top is boys, bottom is girls. You see that the boys are bigger. You also see that there's some overlap. And we also divided these into shorter and longer anogenital distance based on these distributions. And now I'm going to tell you what we found. When the mother's MEHHP was high, that's in the upper 25%, compared to low, the lowest 25%, her boy was 13 times more likely to have a short anogenital distance. This is a very big number for epidemiology. In comparison, a smoker is 10 times as likely to get lung cancer. It's also a small study and the first one, so bear that in mind, but this is a very, very strong finding. And what else went wrong? The boys who had higher levels of DHP had smaller penises, their testes were less completely descended, their scrotum were smaller. So we found a phthalate syndrome in humans. We found a phthalate syndrome in humans. That means that the phthalates in our daily lives that we're exposed to, that massive experiment, one piece of it, is affecting the health of our males. The problem is worse than this, I have to tell you, because it's not just DHP and it's not just DBP. We all know about mixing alcohol and certain drugs, and your doctor will tell you, be careful what medications you mix. We're not very careful about what chemicals we mix in our bodies in this massive experiment. And it matters. Just a quick example. if you take a rat, you give it DHP, low doses, and you give it DBP, low doses, doses that don't cause any problems, for example, no penile malformations. Then you give both of those low doses together, 25% of the animals have penile malformations. This is a new math. 0, 0. Add them together, 25%. And we're adding more than 2 chemicals in our body right now. Where are these coming from? I have to tell you, I love this ad. It was in the New Yorker. Plastics. They're coming from our plastics. They're coming from our food. And how is it getting in the food? Processing the food. Remember those tubes, those soft tubes? Processing the food, the milk coming from the milking machine, and so on and so forth. In the storage, in the shipping, in the handling, in the cooking, all of these places can introduce phthalates into our food. There is an alternative. This is an extreme example. This is an old order Mennonite community in upstate New York that we're studying. And these people grow their own food, they shun plastics in their home, and they have extremely low levels of these chemicals in their bodies. Well, that's pretty extreme. But there are alternatives, and that's something that maybe all of you here can think about and help with. The chemicals I've been talking about, the phthalates, the bisphenol A, are petroleum-based, but they don't have to be. There are alternatives. There are crop-based alternatives, corn, soy, hemp. All of these can be used to make plastics. In fact, Henry Ford built a car made of hemp in 1941, and it ran. So I think we have to think about maybe not getting these entirely out of our lives, but making them better. And they're non-persistent. These chemicals leave us quickly. So we can, if we make these changes, move towards solving the problem. And let me remind you that it is an important problem. Sperm counts declining 50% in 50 years. Testosterone decreasing, testicular cancer increasing. Now remember, I mentioned that these could be all due to changes of the testicular development in utero. And what can do that? Well, we've seen phthalates can do that. And turns out other chemicals can do that. Phthalates are actually just a tip of the iceberg. I think you may know that President Obama said that our children are born pre-polluted. That may be because the Environmental Working Group just showed that infants are getting 397 chemicals measurable in breast milk today. 80,000 chemicals in commerce. Most of them not tested for safety. We assume that chemicals are safe until proven harmful. I think we have to reverse that. We have to reverse the burden of proof so that we make sure that something is safe before it can enter our lives and our bodies and our children's bodies. So at this point, I'm very concerned, and I ask you to consider taking precautionary action for the sake of our health, our children's health, and the health of our planet. Thank you.